Okay, let's take a look at example number 5. So we had a function, the numerator factored into x minus 4 times x minus 2. The x minus 4's canceled off, and that got us to here, okay? So because we still had these two remaining factors, those are our two vertical asymptotes. The x equals 4 gave us our whole. That y value came from plugging 4 into the simplified function. It was bottom heavy on degree, so we got y equals 0 for an HA, and so on. Okay, so I'm going to start by drawing my two vertical asymptotes. So x equals 0, that is the y-axis right here. So you can draw it right off to one of the sides. Sometimes it's helpful to draw a little bit beyond your grid so it's easier to see, but the vertical asymptote is right here at the y-axis. Then we have another one, x equals 3, which is right here. Okay. So that means we're going to have 3 segments to this graph, 3 branches. Okay. My horizontal asymptote is at y equals 0, so that's right along the x-axis right here. Okay, so there's my horizontal asymptote. And we found that for this one, we are going to be allowed to cross it. So let's see how that works out. First, I'm going to draw my hole, so an open circle at the point 4, 1/2. So here's x equals 4, 1/2 will be right here. So there's an open circle there, okay? Then I also have an x-intercept at 2, 0. 1, 2, 0, that's right here. And that's the point where we're going to cross the horizontal asymptote, okay? The rest of it, we don't really know what's going on. So we've got to figure out what's happening in all 3 branches. Now the easiest branch to graph for this particular problem is going to be the one all the way to the right, because we know that once we're out of the middle of the graph, we can't cross a horizontal asymptote anymore, and the only place we're going to cross it was at 2, 0. So this is the only place I can touch. So over here, since the hole is up above it, I need to stay above at all times. So that's going to go like this. So I'm going to be above, it's very close to the horizontal asymptote, so it's kind of hard to see, but we've got that point right there, all right? So next up, I'm going to test some numbers in the middle here so I can figure out what's going on. Like, is this a parabola type thing with a point of tangency here? Is it passing up through it or down through it? What's happening? So I'm going to need to do some test values. So I'm going to go ahead and I'm going to start with x equals 1, which is right here. I want to plug in x equals 1 and see what happens. So I'm going to plug it into the simplified form. So when x equals 1, what does y equal? So I'm going to get 1 minus 2 is -1 over x is 1. 1 minus 3 is -2. -2 squared is 4. So I get -1/4. Actually, sorry, let me write that underneath. -1/4. There we go. Just because I know I'm going to have to test another value, so I'm going to want the space up there. Okay, so when x is 1, y is -1/4. So down here, I need to try to draw on that point. So when x is 1, y is -1/4. Right about there. So that means all of these points to the left of that dot at next to our x-intercept, they're all going to be below, okay? So I know that this is going up and then towards this point. The question is what's happening over here. Is it coming back down or is it continuing up? So now I need to plug in a number here, and unfortunately I'm stuck between 2 and 3, so I'm going to need to do a decimal. I'm going to do 2.5. Okay. So now I'm going to test x equals 2.5 and see what happens. So that's going to give me y equals 2.5 minus 2 is 0.5 divided by 2.5 for x. 2.5 minus 3 is -1/2. -1/2 squared is 1/4. Alright, so this is a crazy number, but that's what your calculator's for. So we're going to do 0.5 divided by parentheses 2.5 times 0.25. That comes out to 0.8. 0.8. So this comes out to 0.8 overall, which is a positive y value. So here at 2.5, I need to go up just below 1. All right. So that means on one side I'm below the HA, and on the other side I'm above it. So this is going to look more like a point of tangency. So we're going to go up along the VA, curve through these points, and then keep going up. Okay. Now that's going to take some practice getting the hang of that, but because we knew that we were crossing right here, we need to know what's happening on either side, so we need to test a value on both sides. Now we've got 2 branches done, we need to do 1 more, so I'm going to need to test another number, alright? But now I'm going to just need to test 1 number over here because it'll either be all above or all below, okay? So I'm just going to plug in x equals -1 and see what happens. So my next text value is x equals -1, okay? So I'm going to go ahead and do that. When I plug -1 into the top, -1 minus 2 is -3. And then x is -1. -1 minus 3 is -4. -4 squared is 16. Okay? So this comes out to y equals +3/16, which is a teeny tiny fraction, but the important thing is it's positive, so it's going to stay above that HA. So I've got a point right about here. Okay? And it's above the HA, so I need to stay above the HA. So I'm going to start above the HA, go through my point, and approach that VA. All right? So this is a pretty crazy looking graph. There's a lot of extra work that had to go into this one beyond all of the key features. So there were a lot of confirmation points that we needed to find. But that's how I created the graph for problem number 5.